Thank you, everyone, for rejoining us for the next talk. Up next, we've got Ankur Jain. Ankur is a senior data and cloud engineer at Enabler, working at the intersection of cloud infrastructure and modern data platforms. Ankur's based in Melbourne, and today he's going to talk about the Duck and the DataFrame, a data engineer's journey with DuckDB. Everyone, a warm welcome for Ankur, please.
All right. Thank you. Good morning, everyone. Welcome to the flock. And since you guys are here with me for 30 minutes, you are the part of the flock. All right. It's awesome to see you all here today. And I'm super excited to take you on my journey, a data engineer's journey with the DuckDB. So who am I? Hi, I'm Ankur. I'm a senior data and cloud engineer at Enabler. I've been building cloud-native data platforms for over a decade now. And currently, I'm helping data teams work faster and smarter with AI. I have to put the last one, because everybody talks about AI. What I live by, I think ducks are the coolest animals. We can have a debate after the talk. I feel like good tooling should feel like magic, and bad tooling should be deleted. And since we are at PyCon, Jupyter Notebook should come with a warning label. Don't use it. All right. Something about us at Enabler, we are just a bunch of cool technical people who wants to make technology work, whether it's data and AI, DevOps, or security. So what's in for the agenda for today? Fun facts about ducks. That's the main part of this talk. I'm going to make you guys believe that ducks are the coolest animals. That's the whole point. DuckDB is secondary at this stage. And if we have time, we're going to talk about the golden circle, what is DuckDB, why does it matter, and how it fits in your data workflows. And since I'm an engineer, and in my circle, we live by show, don't tell, so we're going to do a demo to bring it all back to life. Great. So let's start with the important things. Ducks. All right. Ducks' feet never freeze, even on ice. So they have this counter heat exchange system, which basically keep their feet warm, even on a really, really cold weather, which I feel like is super cool. And it's perfect for Melbourne cold. I wish I had that. In my opinion, it's nature's engineering at its finest, much like we are about to discuss. I want to set the stage by talking about the state of the data pipelines today. Enterprises primarily lean on two kinds of data pipelines. The first one is they generally use big data warehouses like Snowflake and BigQuery. Both are designed for huge analytical workload on distributed computing clusters. And they generally pair it with dbt, a SQL-based transformation tool, to convert their raw data into clean model datasets. The other way that people build pipelines is using, of course, Apache Spark, which is go-to for distributed computing. It excels both at batch processing and real-time streaming. Spark's ability to basically split the data across the nodes makes it a go-to powerhouse for enterprise handling of big data, and it's generally paired with an orchestrator like Airflow. And enterprises generally use a combination of both, if not one, but they generally tend to use distributed computing a lot for all of their data pipelines. But the question which I'm trying to put here today is this always necessary? Why go all in on a distributed computing system like Spark for your data pipelines? And ask anyone, and they'll give you one single answer. Big data. And they're not wrong. With data storage getting cheaper year by year, we are hoarding data like never before. Petabytes of it, piling up in our data warehouses and data lakes. But do we actually process that huge amount of data in every data pipeline? Or are we just overcomplicating things when a simpler solution can actually do the job? So let's get real with me, guys. How many of our data pipelines are actually processing terabytes of data? Some of pipelines do process terabytes of data, but I think most of the pipelines do not. They maybe process gigabytes of it, close to maybe 100 gigs, 200 gigs, but not the terabytes. And traditionally, we have been processing data using pandas or Excel for a small data. There's not a formal definition of a small data, but that's something which I come up with. And then for a moderate size of data, around 100 gigs, we just immediately goes to Spark. And for big data, Spark again, but just a beef-up cluster. And anyone here who have ever used Spark on a moderate size of data know the struggle. Sometimes spinning up a Spark cluster takes 20 to 30% of your whole pipeline runtime just to get going. And don't get me wrong, I'm not bashing Spark. I love Spark. I actually have a shirt that says I love Spark. It's a beast for distributed computing, but using that kind of a heavy machinery for processing a moderate size of data just feels wrong to me, at least personally. I needed something simpler. I needed something much more local, and that's when I found DuckDB. I think it's perfect for that moderate size of data workload, and it's really processed the data at remarkable speed with no Spark overhead required. So what is this DuckDB, which I'm just quacking about? So it's an open source in-process column vectorized analytics database engine. That's my photograph, which my friend took when I asked ChatGPT what DuckDB is. And we're going to talk a bit more about it. So primary database comes in two types. Mostly are in-process and client-server ones, and in-process is like a SQL database, which means it's fast, local, on your machine, great for small transactional workloads. And then you have client and server ones, which are like transactional MySQL or PostgreSQL, analytics ones, Snowflake, BigQuery. They are great for processing large workloads, but they come with extra setup and extra cloud cost. And where does DuckDB fits in this? Right where it's supposed to be. It's in process, which means it can run on your local with no extra setup, but it's designed for analytical workloads, which means you get the powerful queries out of the box without any overhead of setting up the systems or actually extra cloud builds. Let's talk about storage. So SQLite basically stores data in a row-wise format, which means it's great for transactional workloads, means updating a record or something, but really, really bad when you want to do aggregate or sum on it, because the SQL engine has to basically go through all the rows. But with DuckDB, it's a column-wise storage, which means it stores the data separately on columns, which makes it really great for compressing the data, and also really, really powerful for doing aggregation and summing, because all the column is present in one single place. And the last thing where the magic happens is column vectorized query engine. It's a super complicated name for something which is not that complicated, actually. I don't know why they put it like that. In very simpler terms, apart from processing data row by row, DuckDB processes data in batches, basically in columnar batches. In a more simpler term, it's like slicing through a huge slice of data all at once, rather than going it piece by piece. And pretty much that's what the column vectorized query engine is. Now, starting with DuckDB is very, very simple. You do a pip install DuckDB, type DuckDB in your command line, and you're good to go. That's it. It's really that simple. What you can do with it, you can actually query a Parquet file if you want, and then any external Parquet file, you can start querying your CSVs. You can create a table if you have to, like any other database. And you can insert into those tables and then finally query them, like any other regular database. How you can use before I go for there, I really want to touch on the performance of DuckDB. This is a TPC DS benchmark, which I ran around 100 queries. I took a snapshot of 40 of them. And as you can see, it's running on around 100 gigs of data on an M6 2x large EC2 machine. And you can see that DuckDB often outspaces Spark in the purple ones, because its ability to handle the single node transaction is really, really very well. But which I did not put here is, as my data keeps increasing, like terabytes and terabytes of it, Spark's distributed muscle starts to shine. Sparks is really great when you have like terabytes of data. But for the sweet spot, for most of the data pipelines, I think around 100 gigs, DuckDB's ability to process data is really, really hard to beat. And it's really lightweight and does not use too many resources as well. So and in order to replicate this, I'm going to give you a link to the end where if you guys want to replicate the same benchmarks which I replicate, you can also do that. So how you want to use DuckDB? Use it with dbt. It's literally a match made in heaven. I've tried with so many ways to use DuckDB in my data pipelines, and dbt is the best way to do it. And if anyone who does not know what dbt is, it's a very simple SQL-based transformation tool. It lets you convert your raw data into transform data set. It lets data teams basically treat SQL as a code, making it easier to maintain and build your data pipelines. Now, how to set it up? Again, super easy. Pip install dbt DuckDB, that's it. And then you can just change your type in your dbt profiles file to DuckDB and dbt, which actually start using DuckDB as a processing layer, apart from any data warehouse which you have been using. Great, which means we can do a quick demo of what I've been quacking about for the last, I think, 12 minutes. So I'm going to go to my machine, and what I'm going to do is, before it runs, is I'm going to run this dbt command. So what it's basically doing is just processing the not last 3 months, but 3 months of GitHub events data, which I'm going to explain it to you guys in a bit, what that command which I triggered is just doing. So before I explain to you guys what that command is actually doing, I want to make sure that you guys still believe that duck are the coolest animals. Ducks have regional accents, which means technically, you should be able to tell if a duck is from Melbourne or it's from London. It's possible. I have tried it. I couldn't figure out, but you guys should be able to do that. Now, the command which I just triggered, what it's doing is it basically has 1 year of GitHub events, raw GitHub events data, which I'm going to show you in a bit. And it's actually transforming that data into 7 models, which are split into 3 layers of bronze, silver, and gold. Those are just layers are just logical to split the data. And that data have 222 million records. And then a dbt is actually processing that data using DuckDB as its processing layer, apart from any other processing layer like a cloud warehouse or Spark. And then it's actually converting them into these 7 data sets. So the GitHub events is just a bronze data, which means it's just filtering some columns and basically transforming some columns if it has to. Then finally, you have GitHub clean events, which basically means it's removing nulls and all other stuff, and finally creating 2 models, one for dimension actors and one for repositories. And at the end, it's basically creating 3 data marts, which basically you can eventually connect it to your BI tools if you have to. And those 3 BI tools and those 3 models are actually using your silver layer to create the data sets. And those are basically your contribution metrics, daily event metrics, and your repository activity metrics. Now, to show you how much powerful it is, the command which I just triggered, it's processing 3 months of data, October, November, and December. It means it's processing 61 million records, which is 36 gigabytes of compressed data, 142 gigabytes of uncompressed data, running on a 14 GB RAM, and creating 7 models. And if my estimation are correct, it should be able to process all of that in around 5 minutes. One thing more, the data is not stored locally. It's actually stored on Amazon S3. So there is a network cost involved of all the data. The data is partitioned. It's been partitioned by Hive. I have partitioned it on ENR month, but you can partition it in whatever way you feel it's right for the tool. It's actually using Parquet format. That's why the compression was 36 gigabytes, and which is great for speed. And at the end, since it's running on Amazon S3 as a storage layer, the data is already partitioned. It's using Parquet, which means you can actually use it with any other tool you want to use it with. Spark, Trino, Athena, whatever you want, even Databricks if you have to. And one thing I want to point out here is DuckDB is actually increasing their file formats. So they're going to eventually start supporting read and write to Delta and Iceberg, which makes it so much easier to work with rather than just using a Parquet format. Great. So I want to just touch a bit about adoption to people who are new to DuckDB. DuckDB actually skyrocketed at around 2023, as you can see, which actually proves that this is not just a utility tool anymore. It's actually getting more into the mainstream, and community really, really loves it. At the current stage, this is what the adoption numbers look like. It has 30,000 stars on GitHub, 43,000 LinkedIn followers, which is way more than mine, 3 million plus website visits, which is again way, way, way more than mine, and 18 million plus PyPy downloads a month. which proves that DuckDB is not just a niche product anymore. It's actually people are starting to use it in enterprises as well. One really interesting thing I want to show you guys is called the DuckDB UI. I really hate writing SQL on a command line. That's like the worst experience you can ever do. So if you run this command, like DuckDB -UI, it will actually take you to this beautiful tool right here. It's running on my local host and it's actually connected to my to my AWS S3. And this is that raw events table which I was talking about. So as you can see, it has 212 million records, which is similar to that raw GitHub table. And you can actually view the data if the internet allows. Perfect. So this is data which was actually the dbt run, which I just started, is actually processing. It's have the payload for all the information which basically happens on a GitHub public repositories, who the repository was, and some more stuff. And as you can see, it has partitioned by month and year. And that thing has been continued across all the models. Great. So if we go back, and hopefully, if I've been talking for 5 minutes, we should be able to see, and if the internet allows. Our internet is really great here. Yep, perfect. So it computed all those 7 models in basically 5 minutes and 22 seconds. And that's like 32 gigabytes of data, which is a bit better than my previous run of 5 minutes, 23 seconds. Now, what I really want to show you guys, if I go back to DuckDB UI, I can actually create those models. So these are just views on the data which is actually residing on Amazon S3. So I can query it on my DuckDB UI on my local. And these are those models, actually, which are split into silver, bronze, and gold. And let's say if I open any other model, let's see if we can. Yep. So this is how it looks like. So it has 3.27 million records. And DuckDB is also going to process the column level metrics for all of these events. For example, it has done for this one, but it's really slow because of the internet. But I want to run a one query on this 3.7 million records. So it's a group by, so it's going to go through all the records, basically. And let's see how much time it takes to actually run it. Yeah, the internet is really slow. Yeah, sorry, guys. I think I'm not able to hit. Yeah, it's relatively slow. Yeah, hopefully it will come back. But yeah, that's one of the part. Cool. So the whole point of that thing was that you actually are able to process that much data in such a less amount of time, which is just around close to 5 minutes. You were able to process 32 gigabytes of compressed Parquet file and create 7 models out of it, which is really, really great. Which brings us to the next important part of the talk, which is ducks again. You know, ducks can sleep with one eye open. I think that's really, really great. One of my friends does it. I was sharing a hotel room with him, and he sleeps with one eye open, which is like super spooky if you wake up at night and you see one of the eyes open under the blanket. But, but ducks do it, and which is super cool for me. All right, what next? Limitations. Not every tool is perfect. DuckDB only supports single node execution, which means you can't actually use it on a distributed node. It's not suited for write-heavy workloads, which means you can't use it for streaming or heavy transactional workloads. And it has a very limited multi-user support, which means not a lot of people can read and write at the same time. It's great for using as a processing layer or your individual EDAs and stuff, or on your Jupyter notebooks, but it's not great to be just hosting for it. There is an enterprise version called MotherDuck, which lets you do the third one, but you have to pay for it. Next step, I would say if you guys are interested in docs, then DuckDB extension is one of the things to check. One of my favorite one is the Postgres extension, which lets you connect DuckDB to Postgres, which means you can query analytical queries on the transactional data without actually setting up a data warehouse and actually moving data around from the Postgres. It actually turbocharges your EDA, which means it's super great, because you can just run it on your Jupyter notebook, on your local, and it's much better than pandas, and other people who use Polaris don't. And you can also use DuckLake, which is super great. It's like DuckDB fused with our data lake architecture. Takeaway from this talk, I really want to just prove one thing, that ducks are the coolest animals. That's it. That's why I applied for PyCon today. And at the end, I really want you guys to go back, check which data pipelines you think are using Sledgehammer on your data pipelines, and you feel like DuckDB can be a new elegant solution. It's just a pip install away anyway. At the last, really thank you guys for joining the vlog. It's so good to see you here today. And that's the QR code, which will take you to the repository, which I just triggered. It will also take you to the TPCDS benchmarks, which so you guys can replicate it if you want. It's also going to give you a couple of more reading things, which will allow you to read more on DuckDB and the basically extensions and stuff. Any questions? Great. I think we have some time. If anybody is interested, I can show you the code which I wrote, if anybody's want to go technical. You want to go technical? Cool. I didn't do it initially because I thought it was too much, but I can show you guys. So this is the DuckDB code. That's my profiles.yaml, and that's what's showing that it's going to use DuckDB. It's actually locked to just 14 gigs of RAM, even if it was running on a 16 gigabytes of RAM. And then that's my DVD project. It's not doing much. And then I'll start with my models. I will start with my model. So that's my source model, which is just pointing to my raw events on Amazon S3. And then this is my SQL, which is just converting into a bronze layer right over here using my source, and then doing this because it's Hive partitioned. And then it's actually running a SQL query. And then there's the same thing just forward with the intermediate table, which is actually using the same things, but it's just saving them into an S3 part of silver tables. And at the end, and everything is being read and written back to Amazon S3, and it's being using a date filter, so it's actually able to use Hive partitioning, so it's not scanning through the whole database. And at the end, I have these goal tables, which are just hugely aggregation tables using multiple tables. If anybody has used a DBT is just a Jinja-like style format to refer to the tables. The tables don't actually exist anywhere in the project. They are just residing completely on Amazon S3. It's just a way to build these models really, really easy and really, really well, and at the end of the day, storing back to Amazon S3. One thing which I have to do in order to do that is to write my custom macro to actually let DBT read and write to Amazon S3. So this is the way it actually reads from Amazon S3. So it's being using my bucket and certain model path, and it's using Hive partitioning. And this is how it actually writes to Amazon S3. The default configuration set for partition is year and month. But you can partition it whatever way you want. And it's a config parameter, so you can actually pass it, which I did in daily event metrics, because I wanted it to partition by year, month, and day, and not by year and month just. That's pretty much, that's a very simple way of doing it. And then since I was running it on my locally, I also have a custom config to actually load my AWS secret credentials, but because it's using a region and a profile. Those are the three macros which you're going to find it on the GitHub repo as well. But those are my custom macros to read from AWS, read and write to Amazon S3. Because currently, the way DBT and DuckDB works is it only lets you write to Amazon S3 in a Parquet format if you are using directly from the sources of the DBT. But if you have intermediate tables, like from your intermediate or marts table, it doesn't let you write to Amazon S3 in a partitioned way. So I have to custom build that. Pretty much that's the code. Does anyone have questions on the code? Yeah.
The query you were running before, I was wondering, did it get there in the end?
Yes.
one of the reasons for its slowness or otherwise? I was wondering.
So it's mostly slow because of the internet. So it took 491 milliseconds technically, but it was queued for 2.5 seconds because of that, and it actually processed 3.7 million records in 491 milliseconds. And consider the fact it's actually a bit slow because it has to actually go to the Amazon S3, pull the data on my local, and that data is 3.7 million records. And that's why it's got a bit slower. But when I run it on my home internet, it generally takes less than 100 milliseconds to run.
Also wondering how many files per partition there. So you've got like star parquet. Is that one single parquet underneath the hood? Or
No, it's not one single parquet. I don't know whether I have that query available at the moment or not, but the way I was partitioned with, it would be roughly around, the raw data roughly had, so each month has 10 gigabytes of data, and each parquet file is roughly around 250 MB. And when I'm putting the parquet file back, they're not one single parquet file. So the amount which I'm trying to put is around 100 to 150 MB of sweet spot of a parquet. So if the moment it goes more than that, it just start partitioning, start creating multiple files actually, yeah. So it's not one single file, yeah. Cool,
right.
Thank you guys. It was so good.
Can we get a round of applause for Ankur, please? Ankur, thank you so much for joining us at PyCon AU this year. We're so happy to have had you inform us all about ducks and then a little bit of DuckDB as well.
Yes.
In appreciation, I'd like to present you with the what year are we? 2025 PyCon AU speaker's mug.
Thank you.
And again, can we get a round of applause for Ankur?
Thank you, guys.